Hello friends and welcome to YouTube channel Freedom Tech, and in this session what we are going to learn. In this session we have again new project where we are going to create a new custom object detection model which detect railway track crack. We will detect the railway track crack using our own custom object detection model, the YOLO 12. Then we have here Google Gen AI, our own AI agent, which will improve the object detection. Means it will add some more points like what kind of maintenance do we need for particular crack, or let's just say the intensity of the crack. So this is how we will add more features for object detection using Google Generative AI. So this is what our today's project. We will detect the railway track crack. So before we move to our practical, friends, if you learn something from our videos, please consider to subscribe our channel. Also friends, we create a special membership for students only. If you join our channel, it will really help us to create more and more content on this channel. So thank you so much friends. So let's get started. So for that I have created new repository. I will mention the link inside description box. Simply copy paste the link inside web browser as we always do. Then go to the code, click on download zip, and it will download our zip format repository. Minimize the browser, open file manager, downloads. This is what our repository. Right click and we will extract our repository as a folder. So we extracted again same folder. So first we need our video file. So for video file I have mentioned vid.txt. this is the text file. Just open it and you will get the link of the video file, which is basically the mega cloud links. Copy the link, open the web browser, new tab, Ctrl+V, and just paste the mega cloud link. It will open the video file link from mega cloud. Then simply click on download and it will download our video file. So let's just wait. So we downloaded our video file. Close the mega cloud link and just close the text file also. Go to the downloads and this is what our video file, track.mp4. Cut it and move the video file inside our folder. Let's just first watch the video file. So here it is. As you can see, this is the railway track and this is the crack. So this is what our first crack. Then we have here, as you can see, this is the crack. This is the second crack, and then again we have here crack. As you can see, this is the another crack which we have on the track, railway track, and then we have this one crack. Simple. As you can see, this one crack also, and then we have last one crack. Here it is. As you can see, this is the last one crack. So our goal is to detect these cracks using our own model. So for that, of course, we need our own model. So we will send this video file to Roboflow and then we will create our own data set. So for that, first, of course, let's just open the Roboflow. So open Roboflow, just sign up with your Gmail ID, then click on new project. YOLO 12 is the project name. You can mention any name. Then annotation group, object, you can mention any annotation group. Project type, object detection. Click on create public project. It will create the project. Select file and go to the downloads. This is what our folder, railway track. Select the video file and it will now upload the video file. So how many images do we need? For demo purpose we need 41 images. It is more than enough. But in real scenario you need more images. Means you need different kind of railway track crack videos, or let's just say images, for creating more perfect model. But for demo purpose 41 images is more than enough from this particular video file. So 41, choose frame rate. Now it will capture the images using our video file. So 41 images, click on save and continue. So we save our images. Now just click on start labeling. Here you have to mention your Gmail ID, then click on assign to myself, then click on start annotating, and now we have our annotation tool. Simple. So of course we will use the first tool, which is the bounding box tool, first one, and let's just draw the bounding box on the crack, and we will mention the class name, which is crack. Okay, crack. You can mention any class name. You can mention the railway track crack, or you can simply mention the crack. So I have mentioned the crack. This is what my class name, and then we created our class. Now go for next image. Again we will draw the rectangle on the crack like this way. Click on save, go for next image. Here also we will draw the rectangle on the track crack. Save the image, go for next image. Here we will draw the rectangle on this way, like, because this is all the crack, so we want to draw the rectangle like this way. Save it, go for next image. Here also same way, draw it, done, save it. So now this is how I will draw the bounding box, or let's just say I will draw the rectangle on each crack. So let's just wait. So friends, we have done with annotation process. This is what our last image, 41 out of 41. Now just click on here where you will see your project name, which is the YOLO 12. So just click on it. We have done with all annotation process. As you can see, unannotated 0 and annotated 41. Click on add 41 images to dataset. Then the method, we will select split images between train valid test. Select it, the method. Click on add images. Close this small window, and then we have dataset 41. Now we are ready. Click on versions. So now we have done with Roboflow. From here we will leave the page like this way, and now we will first open our Google Colab. So let me open Google Colab. So I have opened the Google Colab. Now click on upload, click on browse, and we will go inside our repository folder. Select the Colab file, and let's just wait for uploading the Colab file. So we uploaded our Colab file. Now let's just go to the runtime, change runtime, select Python 3 T4 GPU, click on save, then click on connect. It will connect. So we connected, and we will run the cell one by one. So let's just run the first cell, then we will run the next cell where we will install Ultralytics. So friends, we have done with pip install Ultralytics. We install our Ultralytics package. Now let's just go for next cell, click on the next cell where we will import all the packages. Then now we will cross check if Ultralytics is perfectly installed or not using YOLO 12 s.pt model, and we will use the doc.jpg image from the Roboflow. So we detected the object one car, one dog, one handbag. It means we successfully installed Ultralytics. Now the custom training, we will create the dataset folder. We will go inside the folder, and then we will install the Roboflow package, and then this is the code from Roboflow to YOLO 12. This is the old code which we want to delete it. So just select it from to YOLO 12 and delete it. And now here we want to mention our new code. So open the Roboflow where we left. This is the page where we left. Click on download dataset, image and annotation format txt. So from txt we will select the latest one, which is the YOLO 12. Download options, show download code, click on continue. Now it will show the code, the same format which we just removed it. Here it is, as you can see, from to YOLO 12. Just copy it and then paste it here. After pip install Roboflow, just press Ctrl+V, it will paste. Then run the cell. So friends, we have done. Now if you click on this small folder icon, there is a dataset folder, YOLO 12, and there is a data.yml file. So here it is, as you can see, this is what our class, and train val test. We want to mention this test train valid path over here. So first one is train. So go to the train, 3 dot, copy path, remove the old path from data.yml file, Ctrl+V, val valid 3 dot, copy path, remove the old path from data.yml file, Ctrl+V, paste it. Test, same way, 3 dot, copy path, remove the old path, Ctrl+V, then Ctrl+S, save the data.yml file. Now this is the main code where we want to mention data.yml file path. So data.yml 3 dot, copy path, go to the here, data is equal to, this is the old data.yml file path, remove it, Ctrl+V, it will paste the new file path which we just copied. Then run the cell. Now it will start our training. So we started our training. It will take some time. Let's just wait. So we completed our process. Our model is ready, and our model is saved inside runs, detect, and train folder. So we will click on the small folder icon, runs, detect, train, weights, and best.pt. Click on 3 dot, click on download. It will download our own model. So we downloaded our own model. Let's just close the Google Colab, then Roboflow also, minimize all these things, file manager, then the downloads. This is what our model, best.pt. Right click, cut it, move the model inside our railway track crack detection folder, paste it. Done. Now first let's just go with the basic object detection. So final.py is the basic code where we have Ultralytics object detection. Tools, manage packages, search for open cv-python, opencv-python. First package, click on install button, done. It will install opencv-python. Then we need Ultralytics package, hit enter. First package, click on install button, done. It will install Ultralytics. Then we need CVZone package. First package, click on install button, done. It will install CVZone. So this is how we need opencv-python, Ultralytics, and CVZone package. Then the best.pt is the model, track.mp4 is the video file name, and then we have here basic object detection. As you can see, the x1, y1, x2, y2. Then we will detect here their center point also. If you want, you can simply show the center point using cv2.circle method. If you don't want the center point, just comment it these two lines, as simple as. And then we have our detection. Then we will put the class name on the rectangle top left corner. So rectangle top left corner is basically the x1 and y1. So CVZone put text rect method. That's it. So this is the basic code for object detection from Ultralytics. So I will mention here a 1 because there is a 0 for going the manual way. Now I have mentioned the 1, so it will go with the while loop automatically. So now we have our detection, and as you can see friends, this is what our first crack we are detecting. There is a rectangle, there is a crack, the class name which we create, which we train. We are detecting the railway track crack, as you can see. Simple. This is the next. As I mentioned friends, we only use here 41 images, but in real scenario you need more images. But this is just a demo, the idea how you can use computer vision for railway safety, or let's just say for railway track maintenance purpose. So this is what our basic object detection. We are detecting the track crack right now using the normal Ultralytics object detection. We create our own custom object detection model. This is the next one, crack. As you can see, we are detecting. And this is the last one, crack. So we are detecting perfectly crack using our own custom object detection model. Now as I mentioned, we will add the generative AI. So for that, let's just close the final.py, and I have mentioned inside the repository, I have mentioned final genai.py. This is the code. So we have our OpenCV-Python, Ultralytics, CVZone. We need LangChain package. So go to the tools, manage packages, search for LangChain. LangChain, first package, click on install button, done. It will install LangChain. Then LangChain-Google -Gen AI, LangChain-Google -Gen AI. Click on search on PyPy. First package, click on install button, done. It will install LangChain-Google Gen AI. So here we want to mention the API key. So let me open a Google Gemini API key page. So I have opened Google Gemini API, Gemini Developer API. Just click on it. It will open this kind of page. Go to the solutions, Gemini API, get Gemini API key, and here we will get the key. So click on create API key. If you don't have any project, create the new one. I have already created a project, so Gemini API, select one of them, click on, it will create the Gemini API key. Just copy it, close it, and open Sony Python ID, and here we want to mention the key. Just Ctrl+V. That's it, done. Now let's just close the API key, and there is no need of browser also now. So we will use the latest model, Gemini 2.0 Flash. We have our video file, we have our object detection model, which is the best.pt we created, and this is the image method, because Google Gen AI need the best 64 image, the encoded image. So for that we will use first this function. We will get the crop image. Let me show you here, because when we detect the object, we are detecting here a object. Okay, so we have rectangle. Basically what we will do, we will crop the image here. Let me show you. Here it is. As you can see, we are cropping the image. Then the crop image we will send to encode image best64 function, encode image best64 function, which will convert the image into encoder format for Gen AI. Simple. And then the encoded image, which I have mentioned as a variable best64 image, and this is the function for encode image. And then because we will use generative AI, and the generative AI which right now we are using, which is the free, so it has some limitations. So what we will do, we will send the crop image to Gen AI, our own agent, every 5 seconds. So it will take some time. So what we will do, we will create here a thread, and we will run this generative AI thread separately, so it will not interrupt our live frame, or let's just say our video file. So for that we use here threading.thread method, and inside that we will call our analyze Gen AI method. Oh, sorry, not method, basically the function. Analyze crack with Gemini. This is the function, as simple as. And then here it is. As you can see, we will get the response. And then our agent. So how do we want our agent to act? Analyze this railway track image and give only the following information in short. As I mentioned, friends, you can add more details for agent as per your requirement. As per your requirement, you can change this prompt. What is your requirement? So I have mentioned here a simple prompt, which is the crack intensity. As I mentioned, the crack intensity of the track, low, medium or high. Recommended maintenance means what is the maintenance do we recommended. I have mentioned like the welding, the track replacement or minor inspection. Simple. So this is just the idea how you can use YOLO object detection along with the generative AI to improve the maintenance of the railway. So now let's just run the code and let's just watch what result we get. So I will run the code. We mention our API queue also. So as you can see the crack, and this is the details: crack intensity medium, or let's just say crack intensity high, and then crack intensity high, recommended maintenance, track replacement. As I mentioned friends, we train only 41 images and we are sending the images every 5 seconds. So crack intensity high and recommended maintenance, track replacement. So for this crack, generative AI recommended we need a track replacement. Simple. For this, let's just say a crack intensity medium welding. Okay, so it says the track intensity, and again as you can see the vision or the image change little bit. So it says the intensity low or minor inspection. Let's just say here what we get, here it says the crack intensity is high and the track replacement, we need a track replacement. Simple. So again the crack, because we are sending the same image again and again every 5 seconds, so it will change the report. So here we get the crack intensity high and the recommended maintenance is basically the track replacement. So friends, as you can see, with the help of generative AI and YOLO object detection, you can make more and more perfect object detection, or let's just say you can improve the object detection for railway maintenance. So for this particular project, I have mentioned the full code along with the video file. Also I have mentioned the Gen AI code also inside the repository. I hope you will learn something from this video. We'll meet our next video. Till then, thank you, take care, and bye bye.